limit algebraically. And there is going to be a super easy way for some problems. Okay? So, if you can plug the number in for x and it gives you a value, that's your answer. So, it's what we call it direct substitution, and it's what you want to try first every time, right? So, any limit, you want to try direct substitution first. So, if I were going to try to find the limit as x approaches 2 of 3x squared minus 4, I would just plug in 3 times 2 squared minus 4, which is going to be, oh wait, what do I do first? Exponent first. 3 times 4 minus 4, then 12 minus 4, which is going to give you 8. In Math 3, that really got a lot of kids the other day. They did 6, and they squared it whenever we were doing a problem like that. So make sure you do, and a lot of times it'll get students here too, so be careful with that. And stuff like this, I don't want you guys using a calculator on it because a big part of our test is non-calculator. So, you know, I mean, you should be able to do that by hand, hopefully, since we're here pretty easily. So don't use a calculator. All right, so you just get 8. That's your answer. If you can plug in the number and you get an answer, that's it. So 8 is the answer. We could look at the graph. We could see where it's at, but you just plug it in. That's all you do. What about this one? Limit as x approaches 0 of 5. Where would I plug in that 0? I can't because there's no x, right? So what this is, it's just a horizontal line at 5, right? So it equals 5 everywhere, no matter what your x value is. It is just 5. Students mess this up a lot of times because it is too easy, and they try to plug that number in somewhere. Like they'll do 5 times 0, which is not correct. There's no x there. So if you have a constant, just a number, it just equals that number, no matter what your limit is approaching. And then if we wanted to do number 3, we would just do square root of 6 plus negative 2, which would give us the square root of 4, which would just be 2. Okay, so lots of limits can be done this way. Obviously, these are not going to be the majority of the problems that I'm going to give you because they're not interesting. We're not looking at, like, interesting things that are happening on the graph. Usually we want to see the interesting parts of a graph, places where there's a hole or an asymptote or something, right? These are just real basic. So you won't see tons of these problems, but you will have some. There are 2 ways that direct substitution can fail, and I'm going to go over that now, but I'm not going to go into what else we do with it until after the quiz. So, 2 ways that it can fail. The first way is if you plug in, like in this case, we would plug in 0 for x, and we get a number over 0. This is undefined, which tells us the limit does not exist. Now, I know that I just used undefined and limit does not exist in the same thing right there. The value 3 over 0 is undefined because that is a value that we're talking about. So this is undefined, but the limit, we would say, does not exist.
0 over 0 equals 1.
Good question. We're just about to talk about it. Where does it equal 0? It has a name. So Coach Wood's a step ahead of me here. Because if we plug in 5 right here, we get 5 squared minus 4 times 5 minus 5. And then 5 minus 5. So 25 minus 20 minus 5. And then we get 0 on the bottom. And then 25 minus 20 minus 5 is 0 over 0. It's not 1. And it's not 0. Okay? So if we have any number besides 0 over 0, so we have 3 cookies and we're trying to put them in 0 groups. We call that undefined, right? If we have 0 cookies, so if you think about it, if we have 3 cookies and we're trying to put them in 0 groups, then, because that's what you can think of with division, right? If we had 3 cookies and we had, 18 people in here, we would divide our cookies out, right? So 3 cookies in 0 groups we can't really do because you have the 3 cookies. So they have to be in a group. They exist, right? So like they've got to be there. So they have to be in some sort of group. We can't put them in 0 groups. So we call that undefined because the cookies exist. They have to be in a group. Indeterminate form, though, here is what we're going to call this because we have 0 cookies in 0 groups. That's not like impossible, right? It's like if you have no cookies, I guess there are no groups of cookies, but it doesn't mean you have 1 cookie, right? It doesn't equal 1, and it sort of doesn't equal 0 because there's no groups. So it's if you have 0, it would mean each 0 for 0, it would be like we got 20 people. I've demonstrated this today. We have 20 people in this room. I brought 0 cookies today. We have 19 people in this room. So everybody gets 0 cookies. Right? More. Yes, who you need? Okay. All right. Well, I guess this is parking lot related. I hope anyway. Hope it's not something else. Officer Sanders is coming to get you. Yeah. All right. So that equals 0, but 0 divided by 0 does not equal 0. It also doesn't equal 1. It's what we call the indeterminate form. And what we're going to see with this, if we see it come up in limits, and in fact, we really should mark out the equal sign there because you cannot have something equal to the indeterminate form. So we would say like this limit is of the indeterminate form. But what we're going to find is if we get 0 over 0, there's going to be more stuff we can do to figure out if there is a limit there. There might be a limit or there might not. We just don't know at this point. Okay, so that's as far as we're going to go right now. Let me flip all the way to the end though. So I don't know if I printed this on there or not. It might be on the last slide. It might not. I can't remember how many slides there were. It's probably on the last slide. All right, so this is going to be your assignment tonight. And I believe that the majority of 5 through 17 odd is direct substitution. So if you finish the quiz early, you can go ahead and start doing those problems. If you get 0 over 0, if you get a number over 0, go ahead and put does not exist. That's your answer. It does not exist. But if you get 0 over 0, leave yourself some space, and we'll teach you how to do that. I think most of the ones 5 through 17 are not. I think they're all direct substitution, if I'm remembering correctly. But if you do get 0 over 0, leave yourself some space, and we'll teach you how to do those later. 51 through 66, I think most of these are ones that we'll have to know more for. But you can start on these if you finish early. All right, quiz. It is on Delta Math. Today, it is okay if you do not have your Chromebook because ClassWise is broken right now and I can't use it. I'm not too worried because, number one, this quiz does not count that much and is not all that important to your grade. So don't risk getting in trouble for cheating over one silly little quiz that barely counts. If you're going to do that, at least save it for a test or something. Here. So don't cheat on this. Number two, you can't photomath this stuff very well. And number three, AI is coming a long way, but I don't think photomath can do the graphs unless they've upgraded since I've seen. Smith's got the paid version, doesn't he? He's paid for the upgraded. He might. I don't know. I'm not paying for the upgraded to see what it will do. I don't think the free version is going to do it anyway. Is your phone back there, Smith?
Yeah.
Okay, good. phones back there if they're not back there. Because Smith is making me doubt whether or not Photomath can do this or not. You're also, it's going to give you different problems than your neighbor, so you're not going to see the same one. So stay on your Delta Math screen. If I come by and you're on something else, I'm going to make you do it over again while you sit right here where I can see your screen the whole time. So I need class-wise to be up there. That power is one of the best things that's ever happened since we started using computers like this. So,
you like the monkey from Toy Story. The monkey from Toy Story.
Yeah. Yeah, that's what I. If you want it, you can use it, but there's not a lot of them that you're going to have to like work out. So most of it's going to be graphs or tables. So if you need it, you're welcome to get it out. But otherwise, I would probably say no. All right, so go ahead and start. It's quiz 1.2 through 1.5. Make sure you're doing the quiz that asks for passcode. If it lets you in without the passcode, you clicked on the practice quiz that was just practice for last night. So go ahead and do that for me. If you get finished, you can do those first few problems from the assignment. Play with Legos. I don't want you to distract the other children, so maybe not today. But it's exactly what we call 0 over 0, indeterminate form. We cannot determine anything. So it's almost like when you get 0 over 0, that should be a big red flag saying keep going, right? Don't stop now, because 0 over 0 should never be your answer, okay? If you have 0 over 0, that means there's something else that you could do. So let's talk about some of the strategies for what else you should do. So try to do this every time. I sometimes forget it. But one of the most missed problems on the test for this is a problem that looks like this right here, and it is a direct substitution problem. All you got to do is plug the number in. Everybody automatically, because it looks complicated, automatically goes to trying to do something to it instead of testing to see if you can just plug the number in. So it's one of the most missed problems, not because it's difficult, just because you forget to plug in direct substitution first time. So we should every time try direct substitution. It's fine if you just do it in your head or on your calculator if it's calculator active part. But I'm going to write it out just so we're clear. So if I do this, I'm going to get 4 plus 6 minus 10 over 0. That is 0 over 0. I'm going to cross out that equal sign because I can't really equal 0 over 0. So this tells me to go further. So the first thing that you are going to do on a problem like this is, if it looks like this, there's a decent chance it'll factor. And I think we did a few of these in pre-cal, but it's been a while. So if we factor the top, and everybody remembers how to factor, right? Okay, so when we factor, because we are expert mathematicians, we need something to multiply to give us x squared. That's x and x. Need something to multiply to give us negative 10, but add or subtract to give us negative 3. What number should I use? Positive 2 and negative 5. Okay, and these cancel. Think about this. I don't know how well we did this in pre-cal, but we did talk about it. If I graph this real quick, can't type. if I graph it, looks like a solid line. It does not look like it has any problems, right? Just looks like a solid line. Do you guys remember what the graph has whenever you have something that cancels like this? A hole at -2. So if I go over here on the graph at -2, if I can get right there, it's going to tell me it's undefined at that point. It's not going to show up unless I do that, because it exists everywhere really close to -2. But if I can do that, there's a hole in the graph. And of course, we're looking at x equals -2. So these are not going to be calculator active. So you're not going to be able to go over and, well, first of all, even if they were, when you graph it on the 84 or the 89, either one, you can't see it good enough to tell there's a hole somewhere. Asymptote, maybe, but hole, no. So even if you could use your calculator, the graph is not going to help you because you can't use Desmos where you could actually find that there's a hole there. But if we look at the graph, what is our answer supposed to be for this limit? No. -7. It's the y-coordinate of that point, right? So if we're pulling it from the graph, it's the y-coordinate of that point. As we approach -2 from the left and from the right, our y-coordinate gets closer and closer and closer to -7. So algebraically, it's really even easier than the graph, in my opinion. Once this cancels, this is going to equal the limit as x approaches -2 of just x minus 5. And once something cancels, just try direct substitution again. The problem that was making you have 0 over 0 is probably gone. And -2 minus 5 equals -7. Okay, I want to highlight something about notation here because our test does have a free response section. And the tests that I give you in class are going to mirror that, so they'll probably be like half multiple choice, half free response. They're on paper. I grade them by hand. So your notation is going to matter way more than it has in any other math class that you've taken in a while, right? Because I'm going to be grading a lot of this by hand. And our final exam, or well, the one that counts anyway. It doesn't count for your grade, but it counts for whether you get credit. The AP exam, they grade those by hand. So maybe they'll pick me to be a grader this year. I think I've been on the list for like 5 years, and they keep not picking me. I've thought about seeing if I could be a pre-cal grader, because I think they're going to need a lot of these this year since it's the first year, but I want to do calculus, but I don't know if they're going to pick me. So, we'll see. Notation-wise, limit as x approaches -2 has to be here until you have plugged in -2. So if you rewrite this step right here, you have to have that limit notation because you have not plugged in -2 yet. Now, could you skip this middle step right here altogether? Yeah, you could. But if you write it, you have to have limit notation. And when we plug in the -2, that's when we don't have to put the limit notation anymore. So right here, I don't have to put limits anymore because I've plugged in the number. Okay, so keep that limit notation on every step. When we start doing the ones that are a little bit more difficult and take more steps, you're going to want to not write it. And honestly, like if it's a multiple choice question and I'm being lazy, I don't usually write it. But if it's something, if free response, you got to write it. So do it on your homework so you're in the habit of it. All right, so does anybody know how to factor x to the third minus 1? Let's check. X squared, what did you say, -1, +1, and then x minus 1. All right, let's check. I might not would write this down yet. So if that gives you any hints, x cubed minus x squared plus x minus 1. No. I mean, it's not a bad guess. I'm pretty sure you haven't been taught how to do this, so if you know how to do this. No, it's not x minus 1 3 times. I would write it down and test it, but I don't want to multiply that together 3 times, so I'm not going to. I'm just going to tell you no.
You pull out an x and then factor it.
Does the second term have an x? No. So They can't pull out an x. If there was an x there, that's exactly what you do. Oh, no, definitely not. Oh, that would... Oh, if we did... Let's just do what Valeria said. Cancel this with this and just have a 2. That kills a math fairy every time you do it. If you cancel when there's subtraction in between the rest of your stuff like that, it kills a math fairy every time. There's been a lot of math fairies die because of things done in this room because of that right there. So we can't do that.
Can you have like 2x minus 1 and x plus 1?
No, it won't work. I mean, we could try it. I'd test it. It's not going to work. I don't think you guys know how to do this. So the reason I'm putting this here is because our textbooks has some of these problems where you have to factor a cube. And I don't think you have ever been taught how to factor a cube. I don't think you're going to have to factor a cube on the exam. I have not seen that except for in like much older exams. They have not put it on new ones. But you might get to college and your teacher might be like, just factor out this cube. And you'll be like, I don't know how to do that. Miss Hyatt let me down. So we're going to do it. So we've done it. So let's write the formula over here. The formula looks like this. A cubed plus or minus B cubed. If you're trying to factor this, you are going to get A plus or minus B times A squared minus or plus AB plus, it's plus, isn't it? B squared. Should I go look that up just to be sure? Maybe. I'm pretty sure I've got that one memorized. Yeah, I've got that right. Okay. Got it. Alright, so. Okay, so this is the formula that you use. You're not going to see this a lot, but this is one of those things I'm throwing in there. Especially if you get an old school professor for something, they might expect you to know how to do. This is something we used to do a lot in algebra too. And we've kind of got away from it because we rely on technology a little bit more. Was that the triangle maybe? Was it like the triangle with the ones? I might have had to do that. I can't remember.
Oh, that's quadratic formula.
Yeah.
Oh, yeah, it's not quadratic formula. It kind of looks like it, but it's not. So, things to notice here about this formula. Right here I have a plus or minus. Here I have a plus or minus. What happened right here? Minus or plus. That means the signs right here match. The sign right here is opposite. So, in this case, this does not look like two things that are being cubed, but what is 1 cubed? 1. So this could be 1 cubed, right? Sometimes it'll be like 8, and that would be 2 cubed. So you need to make it a number that's being cubed. So the way we would factor this, we would keep our limit notation. We would have x is our a, right? Minus 1. And then we got to have the a squared, in this case it's our x, so we'd have x squared plus, because we're using the opposite sign for that second sign right there. And then we do a times b, which is just x times 1, so just the x right here, plus our b squared. Our b in this case is a 1, so 1 squared just equals 1. If you don't believe me, if you think I made this up to torture you with, if we multiplied it back, x cubed plus x squared plus x minus x squared minus x minus 1. These terms right here cancel. X cubed minus 1. If you just want to check to see if you did it right, you can multiply it back. So we have factored that. So that's called a difference of cubes. Difference of squares are the ones that are easy. Just x plus 1, x minus 1, which is kind of like what Kayla was trying to make it into, which is a reasonable guess at this if you've never seen it before. But unfortunately, it doesn't work. It'd be nice if it did, but it does not. So now these can cancel. Once those cancel, you are just doing the limit as x approaches 1 of x squared plus x plus 1, and you're just plugging in your 1. So that's going to be 1 squared plus 1 plus 1, which is going to give you 3 for that. I think there's one on the homework where you have to do this. I think. If I remember correctly. Alright. I don't think that'll be on like a test, but it might be something I like to throw in as like a bonus question somewhere on something. So keep it in the back of your mind. There. Alright. Let's review rationalizing. We did this in pre-cal. Rationalize in pre-cal, we said we can't have square roots in the bottom of a fraction, right? We would have to rationalize the denominator, which means we got to get square roots out of the bottom because they're not rational numbers. There's crazy decimals that go on forever. So I told you had to do that in pre-cal. The good news is, in calculus, on the free response questions, you never have to rationalize. You can leave your answer 1 over square root of 5. And I tell you to do that because you might mess up when you're trying to rationalize. We still need to know how to do it because on the multiple choice section, they may have rationalized the denominator, so we won't know our answers match if we can't do it. But this is just a review that's going to get us into the next step. What do I do if I want to get that square root out of the bottom of that fraction? Perfect. Square root of 5 over square root of 5. I can do that because what is square root of 5 divided by square root of 5? It just equals 1. I'm just multiplying by 1, which doesn't change the value of anything, right? So whenever I do that, multiply straight across, I get square root of 5 on top. What is the square root of 5 times the square root of 5? Just 5, right? If you want to, square root of 25, but square root of 25 is just 5. Okay, remember doing that? I hope. All right. What do we do if we have this stuff? That's more complicated. Perfect. So we have to multiply by 2 minus the square root of 6. So it's not just multiplying by the root like we did in the simpler case. We got to multiply by what we call the conjugate. Let's write that down. I'm going to try my best to expose you to fancy math words, because sometimes when you get to you got to think when you get to college, if you're going to take, I mean, some of you are like, Miss Hyatt, this is the last math class I ever want to take, and it might be the truth. You know, you might not have to take anything beyond here, but some of you are going to go to math classes beyond this, and those classes are going to be taught by people that have PhDs in math. I do not. I have a 4-year degree in math, and I am a commoner whenever it comes to mathematics, and I'll tell you to do stuff like the love connection. PhDs in math might use fancy words and expect you to know what they are. So I'm going to try my best to throw that out there. This is called multiplying by the conjugate. Okay, so the conjugate is whenever you have like a binomial, it's the exact same except for you change the sign in the middle. And the reason that we do that is because it creates a difference of squares in the bottom. So in the top, I could either leave it factored, or I could distribute that 8. Either one, it's not going to simplify either way. But in the bottom, I would do 2 times 2, which is 4. I would do 2 times the negative square root of 6, but I would also do 2 times the positive square root of 6. And what happens with those middle terms when I do that? They cancel out, which is the reason we picked this in the first place, right, to get those roots to cancel out. And then I would do square root of 6 times negative square root of 6, which is going to give me negative 6. And so this would be 8 times 2 minus square root of 6 over negative 2. If I don't distribute, well, either way, you can reduce that because that 8 and that negative 2 could reduce, and there's multiplication in between, so it's okay to reduce those things. So if I reduce, this would be a 4, this would be a 1, so that would be 4 times 2 minus square root of 6 over negative 1. You'd probably see it written like this, negative 4, 2 minus square root of 6. Or they may distribute that negative 4. Because that negative, I could write it in the bottom here, or I could move it up to the top, which is what you're more likely to see. Okay, questions here? All right. There might be times you have to simplify your answer like this to see if your answer choices match, if it's multiple choice, but we're not going to do a lot of this. But it directly relates to what we've got to do with the limits that we're about to see next. So, here is a limit with a square root. I didn't do it on one of the last problems, but if I do direct substitution, I got 0 plus 1 minus 1 over 0. That gives me the square root of 1 minus 1 over 0. I'm getting 0 over 0. That does not work. Right? Indeterminate form tells me I got to do something else. So, what we want to do when we see a square root here is we want to rationalize, in this particular case, we're going to rationalize the numerator. Wherever the square root's at, we want to get rid of the square root on that side of the fraction. Because a lot of times if we do that, something will cancel. So, we'll have the limit as x approaches 0 of square root of x plus 1 minus 1 over x. And we are going to multiply this by the conjugate. The conjugate for this is square root of x plus 1 plus 1. Notice the only sign I changed right there was the sign between my two terms. Don't change the one underneath the square root. It stays the same. And then make sure, if I do that, I also have to multiply the denominator by that as well. All right, so these problems, make sure every time you're writing that limit notation, don't get lazy about it. So if I distribute here, square root of x plus 1 times square root of x plus 1 is just x plus 1. When I distribute here, I will get 1 times the square root of x plus 1. But when I distribute here, I'll get negative 1 times the square root of x plus 1. So those middle terms cancel, which should happen every time. That's why we chose the conjugate that we chose. And then I have to multiply the negative 1 times the positive 1. So I get a minus 1 here. Don't multiply the denominator together. What we want to happen here is we want something to cancel. So we want this, if you do multiply it back together, you're going to have to end up factoring it back out later. So don't multiply the denominator together. All right. Anybody see anything that's going to happen here? What has to cancel first?
The 1.
The ones have to cancel first, right? Because if they have that plus or minus anything, I can't cancel the x's. That would be the canceling that kills math fairies. So I have to cancel out the ones first, but then once I do, I'm going to write it as a separate step, but if you don't, it's not going to matter that much. I've got this. Now, I just have an x on top and an x on bottom. That x right there is multiplied by this stuff, so I can just cancel those. Now, if you don't write that as two separate steps, if you realize, oh, my ones cancel, and then I just have an x I can cancel. If you mark it out in two places, that's fine. So, make sure, though, nothing's left on top. So, what is on top? A 1, right? We have to have that 1 on top. And so we get 1 over the square root of 0 plus 1. We're just plugging in our 0 now. And that gives us 1 over square root of 1 plus 1, which is going to give us 1/2 as our answer. Now I have showed maximum work here, and I'm going to do that on most of my problems. If you skip a few steps, it's fine, as long as you're getting the right answer for stuff. Okay. Now, if you just put this equals 1/2, that would be suspicious and would not get you credit. But if you skip some of these middle steps, it's fine. Okay. Ooh. This is a complex fraction. Everybody's favorite, right? Whenever we take fractions as if they weren't fun enough and put them inside of other fractions. So, in general, we'd rather not have complex fractions. So when we have fractions, we can do dividing fractions, easy as pie, flip the second, and multiply. But in this case, in the top, we don't have a single fraction, right? We got two things that are subtracted here. So you have a couple options of how to deal with this. Is there something? So I would probably suggest getting common denominators in that top fraction first, so you can make it one single fraction. Although there is another way that I might show you on some different problems, but right now let's do common denominator. So if I want common denominator here, if I look, right now I'm kind of ignoring the bottom. I just want common denominators here. My least common denominator would be 2 times x plus 2, right? So I would have to multiply this fraction by 2 on top and bottom, and I would have to multiply this fraction by x plus 2 on top and bottom. I'm kind of leaving the bottom, the denominator of the big fraction alone. Okay, so whenever I put this all together, now my denominators right here are the same, so I can just write that one time. And then in the top, I'm going to have 1 minus x minus 2. Why did I make that a minus 2? This negative 1 right here has to get distributed to both of those. You might want to write a separate step on that. Oh, it should be 2. Thank you. And then we got an x right there. Okay? What is going to happen up here in the numerator of the numerator? 2's cancel. So this 2 and this 2 cancel. And then I'm going to do this. I'm going to go ahead and put this x right here over 1. Maybe I'll put some extra parentheses. So I'm going to go ahead and do my flipping and multiplying now. I got limit as x approaches 0 of, make sure you keep that negative, negative x over 2 times x plus 2 times 1 over x. Okay, you got multiplication in between here, so the x's can cancel. The negative did not cancel. The negative is still there, but the x's can cancel. And so if we multiply straight across, we're going to get negative 1 over 2 times x plus 2. And something has canceled now, so this is when we want to try direct substitution again. So we will have negative 1 over 2 times 0 plus 2, which is negative 1 over 4. So negative 1/4 is our answer. Yes? Once you plug in the number. So once you see where I have taken this 0 right here and plugged it into the equation right there, that's when you can drop your, could and should drop your limit notation. Okay, so You've got to keep it the whole way until you have plugged in that number for the variable. Good question. Because that notation is something I've tried to get better and better about focusing on notation because I like to be lazy and do things fast, which is fine on a multiple choice problem, but is going to really get you on a free response. So I try to model that for you guys here too. All right, questions? Oh, here's the delta x. So, a note for this. These look crazy. Delta x is a separate variable. Some textbooks don't even use delta x's anymore. They just use a different letter. They'll use like an H. So our textbook has chose to use delta x, which means like the change in x, but you could treat it like it's a H or a K or a Z or some other variable, right? It is a single variable. It is not delta times x. It is its own variable, right? So whenever you see it, you're thinking of delta x as being just one letter. It does not mean something times x, okay? So these problems are weird, but not terribly, terribly difficult. But they're a little confusing because of the notation, I think. They look scary. These are the ones you need to go home and show your mom that you're doing. And she's like, oh, my baby's so smart. And it tells all her friends about how smart their baby is. Because it looks scary. For this is a separate variable. Could I do this? Boom, it's gone. Can I do that? What? I just killed a math fairy somewhere. Don't do that. Because you got all kinds of plus and minus signs up here. Everything's not multiplied. We can't do that yet, right? It's what we eventually want to do. I forgot. I need to do direct substitution. I know I'm going to get 0 in the bottom because delta x will become a 0. Let me show you direct substitution on this. It's a little weird. If I try direct substitution, I got 2 times x. Don't plug in 0 for your x. Only plug it in for the delta x. And so that would give you 2x squared minus 2x squared over 0, which is 0 over 0. So that doesn't work, right? So what we want to do on this, on some of them we need to factor. On this one we actually need to like multiply it back. We need to expand. So x plus delta x squared, I would suggest, I think you guys were pretty good last year about doing this part in your head, square, double square. If not, remember that's x plus delta x times x plus delta x, and you can do that over to the side if you need to, but I'm going to square, double square. So x squared is x squared. X times delta x and double it is going to be your middle term. So 2x times delta x. And then the last term of that is going to be delta x squared minus 2x squared all over delta x. Okay, if you need to, over to the side, distribute here, you'll get the same thing I got here in the middle. Okay, here. All right, we're going to distribute this too. So limit as delta x approaches 2x squared plus 4x delta x plus 2 times delta x squared minus 2x squared. All right. Can I just start marking out delta x's now? I cannot. Still plus and minus signs all over the place. Stuff is not multiplied, right? Do you see anything that could happen here? the 2x squared and the negative 2x squared, when we combine those, they are 0, so they go away. And this should happen on every delta x problem that you see. What do you notice about everything that remains here in that numerator? What does... They all have delta x's, right? And that should happen. If it doesn't, you probably messed up somewhere on a delta x problem. Since they both have delta x's, what could I do with one of those delta x's? I could factor it out. So I've got the limit as delta x approaches. Oh, I haven't even been writing my 0 here. I'm going to factor out that delta x. So that'll be 4x plus 2. I'll still have 1 delta x that's there with my 2 over delta x. Okay. Can I mark out delta x's now? The outside one. Not the inside. That would kill the math fairy, but the outside one can be marked out because it's multiplied by the stuff in the parentheses. When you have multiplication, you can, delta x over delta x equals 1. We can cancel those out. So, now, as soon as something cancels, now what we're looking at is the limit. No. I took one out. So, it's not supposed to be there. So, I got 4x plus 2 times delta x. So, whenever we're doing this limit, delta x equals 0. Delta x, not x. Right? So, when I plug in, I'm just plugging in 0 for my delta x. That means your answer for this problem still has an x in it. I got 4x plus 2 times 0, which means I'm just getting 4x. So you actually still have an x in your answer here for that. And sometimes you have delta x problems where you get just a number, but most of the time they do still have an x left in the problem, in the answer. There's a reason I'm making you do all that stuff right now too. And when we get to Unit 2, you're going to see some delta x's again. But right now, just treat it as a separate variable. There. Okay, so that should give you an example of everything that you will see. Hopefully you were able to get a lot of 5 through 17 done. That should be light work. 51 through 66 is where you're going to see the ones that are more difficult. Remember what I asked for you. You got about 10 minutes, so you're going to go ahead and get started on it right now. What I ask of you on homework, and this applies in calculus more so than all the other classes, because you're more likely to run into something like that you don't know how to do here because the work's harder. On homework, try something on every problem. Okay? So do not be like, get to 62 and like, oh, these are hard. Ms. Hyatt, I don't know how to do these. I'm not going to give you full credit on the homework. At least write the problem down and like try a first step or something. Maybe try canceling something or trying to factor or something. Even if if you know it's not, you're not going in the right direction, put a big star next to it. We'll come back and we'll look at it. You don't have to have it right to get credit on homework, but you do have to have something. So make sure you try something on every problem. Okay? All right, so hopefully you can get a few done before you go, so you don't have too much tonight.